We're starting with geometry and measurement this week. I want you to know these terms. Okay? What is a parallel line? Yes?
Lines that never meet.
Exactly. No matter how far you draw these lines out, they will never meet. What is a perpendicular line?
Two lines meet and make a right angle.
Exactly. So parallel lines, well, actually, these are parallel lines. Okay, the lines on your page, those are parallel lines. Perpendicular looks like this. And it makes a right angle. What's a right angle?
90 degrees.
90 degrees. So it makes a 90-degree angle where it meets. What's a perpendicular bisector? Think bicycle.
Is it like split?
Oh, jingle.
Two. Yeah, so a bisector divides a line into two sectors or two equal parts. A perpendicular bisector,
Is it when it does the root plus?
this line is the same length as that line.
Oh.
Okay? So a bisector, a perpendicular bisector, divides a line into two equal parts or into half. At a right angle. So if that's what a perpendicular bisector is, what do you think an angle bisector is? I want you guys to try and come up with this yourself. Think about what a bisector is. What does a bisector do?
I think it separates them into two.
Into two
Angles.
two equal angles. Okay, a bisector divides something in half. Okay, two equal parts. A perpendicular bisector divides a line into two equal lines. An angle bisector divides a line into two equal angles. Do you remember what the little line means there? Here and here?
No.
It means it's the same. Okay, so these two lines are the same. If you look at a square, I'll just draw it up here. You can draw a square like this, even though my square is not actually probably perfect. By this, you know that that line, the length of that line should be equal to that line, should be equal to that line, should be equal to that line.
And then there's like the two lines, right?
Yeah, and then if you had, for example, a rectangle, those two lines are equal. And those two lines are equal. And I can't have one line to show that these are equal because that would mean that they're equal to these ones. So I put two lines. So an angle bisector divides an angle into halves or into two equal parts. Two equal angles. Sorry. Parallelogram.
Oh.
Yeah.
It's like a shape. It's like a rectangle sort of thing.
So it's a quadrilateral,
Quadrilateral.
four-sided figure.
With lines that connect them.
Yeah, to be a quadrilateral, it has to have lines that connect. Quad is four. So quadrilateral has four sides, a four-sided figure that...
All the lines are parallel?
How could you have a four-sided figure if all the lines are parallel?
Oh, no.
Two lines are
The
parallel.
lines opposite to
Yeah,
parallel?
okay. With two sets of parallel lines. So it can be either a rhombus, which is basically a square on its side, or a parallelogram, which is, which is a rectangle on its side. Yes.
So what's a trapezoid?
Base. What is the base of the parallelogram?
It's the bottom line.
It's the bottom line.
It sounds really awesome. It's the bottom.
Not that kind of bottom line. Although in a parallelogram, the bottom line is equal to
Top line.
the top line, yes. By the way, one of the things I didn't show you, which I probably should, is this signal here, like that.
That's a line.
That shows you that the lines are parallel. So here, in the parallelogram, these lines are equal to each other, but they're also parallel to each other. These lines are equal to each other, but they're also parallel to each other. So you use this little arrows like that to indicate that lines are parallel. You use lines like that to indicate that they're the same length. Yes?
I'm confused. Like when you say parallel, it's two lines that will never meet.
Yes.
Like
No matter how far I draw these lines out, if I drew them out from here to Texas, they'd still not meet.
when you
They would still be parallel.
how do they get like
Yes, but this line and this line will never meet. So those two lines are parallel, which is why it's two sets of parallel lines. Because these two lines are parallel, if it's drawn properly, which this one isn't. And these two lines are parallel. So these two lines will never meet. And those two lines will never meet. Those lines are parallel to each other, but not here. These lines are parallel to each other, but not to there. Okay? Yeah. Same question? Okay. Okay, so the base is basically the bottom line of a figure. And the height
The side.
is basically the side of the figure, side line. It's not exactly that. It's the height is from the base to the top line. Okay, so this here is actually the height of the figure. From here down to the bottom there.
Oh.
This is not the height, this is the height. From the top line to the bottom line.
Do we actually have to measure those, or we just
There will be ways to figure it out, or it'll be given to you. What's the area? Not formula. What does area mean? When I talk about the area of a figure, what am I talking about? Probably the easiest way to describe it is the space within a two-dimensional object. So like a flat object. And we say that because volume is the space within a three-dimensional object. Okay? This, all of this is the area. Thank you. All of this inside that box is the volume.
oh that's not a two-dimensional.
That's not two-dimensional because it's got a third dimension called depth or width.
Okay,
So this would be base times height. This, usually we say length times width times height, but in essence, that's the base. This is the height, and this is the width.
And that's measured in units cubed.
Exactly. So area is measured in units squared.
Oh, and then you have the cube.
Like, for example, meters squared. Volume is measured in units cubed. For example, meters cubed. Any questions so far? Yeah.
There's such thing as like meters. This is the one before.
Usually we just say to the power of 4. At that point, we usually just say to the 4th power or to the power of 4. However, the 4th dimension does not come up in mathematics until you get to theoretical mathematics. So you guys will not need to deal with that. Time.
Oh, the time.
Basically what happens is you have first dimension. If you square the first dimension, you have the second dimension, or 2 dimensions. If you square the second dimension, you have the third dimension. Okay. If you square the third dimension, you have the 4th dimension, and I don't know how to picture that, and I'm not entirely sure anybody does.
Maybe still swirly.
It could be. I don't really know. But in terms of concrete pictures, I can draw you first, second, and third dimension. I cannot draw you the 4th dimension. Yes.
Why is the
Time.
dimensional line?
Because that's the first dimension.
You could draw clocks. You look at it.
Was it like
I could, but it's not quite the same thing. Okay? So, first dimension, if you square the first dimension, turn it into a square, you've got this. If you then square that, you've got this. So this would be meters. This would be meters squared. This would be meters cubed. This is a line, or distance. This is a box, or area. And this is a cube, or volume. Any questions about the terms? Yes.
Will we have to learn these for the test?
Yes and no. You'll need to know what they mean, but I'm not going to quiz you on the terms themselves. I may ask you to draw parallel lines and perpendicular lines, or identify parallel lines and perpendicular lines, or how you can tell a line is parallel or perpendicular. I'm not going to ask you to define the word parallel or perpendicular. Any other questions? Yes.
Yeah, another minute to copy it all down.
Sure. If that's it though, I'm gonna pause the video